What are you talking about? Taco Fusion South, that's what I'm here for. Okay.
Yes. 0.58 is what kind of thing? It is what kind of thing? Is it a, what the hell are you talking? Cat? Is it a z-score? No, hell no. It's an area. It's a percentage which we now know is related to areas of the visual of the probability distribution. So that's an area. Where are the areas on this chart? Where are the areas? In here, right? Don't look up 0.58 and think that means anything. I don't know what the z-score is, so don't look up 0.58. Doesn't make any sense. I don't know what the z-score is, so I can't look here because I have to know what the z-score is to look here. So what's the closest you can get to 0.58 in here? Yeah, it's one of these two up here. Do you see that? Which one is closer to 0.58? Let me say this and see if you get it. That's 32 away from 0.58. And that's 7 away from 0.58. Can you guys see that? 5793 is like 0.0007 if you want to be all exact. Who gives a shit about exact when you're just trying to see who's closer? That's 7 away from 5800, right? That is 32 away from 5800. Which one's closer? The one that's only 7 away. So what's the z-score then? 0.20. I like it. I heard a what? Somebody go, what? Or maybe you go, what? Oh, there it is. Alright. 0.58 is the area I'm trying to find. What did I do from the very beginning? I had a z-score and I looked up the area. I looked at the z-score and then went, yoop, and found the area. Now I know the area, so I find it. Well, the closest I can get is between these two. That's the closest one to 0.58. And then I look out, what z-score? 0.20 is what leads to 0.58. I'm just doing the first thing we did backwards. If I know a z-score, I go, if I know an area, I go, right? Just do the opposite. Math can go both ways. Don't judge. So that's 0.2. That's the z-score that has 58% below it, and that's why that's the z-score that is the 58th percentile. That is the definition of a percentile. This one is pretty much the same idea, except where is the 5% it's talking about? Above the z-score. So where is the z-score going to be? It's got 5% above it. It's going to have to be way up here, so it's only got 5% above it. Does the z-score chart understand areas above? No, it only understands areas below. So if I got the z-scores at 5% above, what percent does it have below? 0.95. Now try to look that up in the chart, see what you get for a z-score. Don't say it out loud. This one's going to have a little interesting thing happen. You're all like, I don't know if you can handle more interesting things. I don't know, you'll find out. Then you should know. That was a neat trick in that little conversation. What do you mean? So trying to get as close as you can to 0.95. If you don't have something interesting happen, you're doing it wrong. What's the closest I get to 0.95? Right in between those two, right? So now if you follow this, it'll show you. But what's this one? This would be 1.64. Is that cool? That side would be 1.64. That side would be 1.65. So what's right in the middle? 1.645. If you follow this down, 1.645. That is one of the most commonly occurring z-scores. That's why it's given its own little designation. So this is 1.645. How are we doing? That's it. That's all it asks for, right? What's it ask for? The z-score that has 5%, I'm done. I got the z-score. That's got it. That's it. I love that. And then what? That's too short of a problem. Well, then love the shit out of that. Right? All right. Now, let's go back to these. Comparatively, these should not be too bad anymore. Holy crap, they got the brightness cranked up. All right. So some of you guys are not going to draw the picture. That's great. You're the ones that are going to make the really silly mistakes more often. So it's your choice. There's 0 there. Where's 1.51? To the right. It's asking for the area below that, which kicks ass, because that's what the chart tells me. What do you guys get when you look up 1.51? Yeah, 1.51. 0.9345. Kick ass. What does that mean exactly? What about 93.45%? Yeah, there's 93.45% of what? Of the z-scores below a z-score of 1.5. So if I had a test that was normally distributed, what percentage of the students had a test score that would have a z-score less than 1.51? 93.45%. Something that is normally distributed that we deal with all the time are heights. I think I said this before. Heights are normally distributed. We have most people are somewhere close to the average, and then you have like really tall people, really short people. The word unusual makes sense because if you saw somebody really tall, I'm talking about 7'7" or something, you go, whoa, that's unusual, right? If you saw somebody really short, you go, whoa, I don't see that all the time, right? I'm not saying that the person is weird. I'm saying that from our experience, that is weird.
Don't stare.
You with me? Yeah, don't, stare at the poor people. Where am I at? Oh. I don't know what else I was going to say. Well, what about part B?
Can you do the first one to see if I did it right?
Dude, I did the first one. What do you
The
mean?
second one. The second one.
The second one, okay, sure. The one I just talked about?
Yeah.
Okay. Where's negative 0.96? A little bit below. And I want the area above that. So if I look up negative 0.96, I get, I get 1685. So you guys got 1685. Where's that go in the picture? Yeah, always below. Whenever you look up a z-score and you get an area, it always immediately goes below the z-score you just looked up. Because why? Why is that? Because that's what the freaking chart does. That's all. That's what the chart does. And how do I find the actual answer I want? Because I want this area. 1 minus 0.1685 is 8315. And if you like the shortcut, you can look up positive 0.96, and that would get you to the answer immediately. It's just that if you're not sure when to do that, just never do it. Yes?
So if we do the shortcut, will we be deemed for not showing the word we do?
You still have to show me something. Yeah, but no, you're not going to be deemed. That'd be evil. Here's a great shortcut. Never use it. All right, now this one. Negative 3.21 is way the hell down there. 1.98 is somewhere up that way. And I want the area between the two. So if you look up 1.98, what area do you get? Yeah, 1.98. I like it. 0.9761. That's 0.9761. What about negative 3.21? Yeah, negative 3.21, 0.0007. So how do you get the area in here? Subtract those two. So you get 0.975. I like it. If you happen to be somebody who took stats before and you didn't do so well and you're taking it again, I don't give a shit what your last teacher let you do. If you know the buttons to press to make your calculator spit this number out at you, I don't care. You do this shit, right? Because if you have the calculator do stuff for you, you're not learning it. You're not. And if you don't want to learn it, it's too bad. Okay, so that's number one. Let's talk about what to do for problems like number two. Somebody remind me, what is the z-score formula? Yeah, it's the distance from the mean divided by the standard deviation to see how many standard deviations fit in there. That's why the z-score does what it does. So, to translate what she said into mathish, what she said is perfect. The z-score formula is x minus the mean divided by the standard deviation. I like it. It doesn't change if it's a sample. I mean, why is this one for a population? How can you tell? Yeah, it's got the mu and the sigma, the freaky Greek letters. It's the same formula for a sample gathers. It's just got to use the right letters, but the idea doesn't change. So, if I knew that men's heights were normally distributed, with a mean of 69 inches and a standard deviation of 2.8 inches, let's say. Those are close to right. All right, so the average dude, the average American dude, is 5'9" tall, and the standard deviation is 2.8 inches away from that. We know they're normally distributed. We actually know that. They're close enough to normal. What's the probability that if I pick some dude, they're going to be taller than 74 inches? All right, so the immediate problem is all my numbers are X scores. They're what we call raw scores. They haven't been processed yet. Right? What's the only thing that the z-score chart works for? Well, the name tells you it only works for z-scores, right? So the only thing that this kind of problem does is it adds one step. I have to convert all my raw scores into z-scores. If it's normally distributed, that z-score chart has to be true for it, period. Doesn't matter what it looks like, they're going to fall into place when you make everything z-scores. So if I graph this, what's right in the middle for this problem? Good, 69, that's the mean. So underneath it, I'm going to put in parentheses the z-score. And the mean always becomes what? Z-score. What's the z-score for the mean? 0, because the z-score is how far away from the mean is. Okay, that's 0. What's the number we're interested in? What's the height we're interested in? 74. Right? I want to know greater than 74, so I better find 74 on there, and I think everybody could find 74. And I want greater than that, right? So I got to convert 74 into a z-score, and then I can do everything we just did. That's the beauty of it. Once you get z-scores, you can do like we did in number 1. So go ahead and convert that into a z-score. It's just a formula you plug stuff into, so it shouldn't be overly taxing. Part B here in a minute. So how do I set up the z-score? Z equals x minus the mean divided by standard deviation. So what's x? What am I trying to convert into a z-score? 74. Minus the mean, 69, divided by 2.8. I'm just going to sit there and watch me try to do my... Don't do that to me. What is it? 1.785? So 1.79. Is it really 5 or is it... Why do I round it 2 places? Z-score chart goes to 2 places. All right, that's only makes sense. So is it 1.79 if you round it? Yes? Okay, cool. Look that up on the chart. I'm going to put that on my little. What do you guys get when you look at 1.79? 1.79. 9633? Yeah. I like it. So where's that go in the picture? Good. 9633. So what's this? Zero, 3, 6, 7. Okay, cool. So almost what percentage of men are taller than 74 inches? Almost 4%, like a little over 3.5%. Either way you want to say that, just summarize it. Are you guys with me? So if I had a doorway that was 74 inches tall, what percentage of men would have to duck to get through that? 3.67%, almost 4%. Do you guys? So if I was trying to design a building where less than 2% of men would have to duck, I could figure out what z-score relates. In fact, let's do that. That's part B. Let's design. I want to design a doorway. I want to know how tall does the door have to be so that at most 2% of men, American men, have to duck to go through it, or not pay attention and something like that, right? How the hell do I draw? I want how tall should the door be for at most 2% of men to maybe bang their heads, to duck, to get through? Oh, shit. Is that a very tall door or a very short door? It's going to be on the taller side. So I want at most 2% of men to have to duck. So wherever I put it, where's the 2% going to be? Who would have to duck? The people that are taller than the door, right? So this would be 2.02. All right, maybe. What can I find from that? Do you see how this problem starts with a percentage? Let me show you this real quick. Let me see what you guys think about this. A normal z-score problem. This is your normal z-score problem. You start with an x, right? You change that into a z-score. And then you look up the area. You guys see that little, I like that little summary. That part B started with a percentage, and it's asking me for how tall the men are, which is what X is here, right? So I'm given a percentage. Okay, I better make a z-score out of it. And then I better freaking change that back into an X score. So that order of things as we follow. Just sometimes you'll start here, or sometimes you'll start there. So how do I figure out what z-score goes along with that? What's the z-score for this? How do I figure that out? Well, what's wrong with the area I know? It's above. Shit. And the chart only sends areas that are below. So what area is below this? 0.98. So what's the z-score for that then? 2.05. That sounds right. You guys with me so far? Now, obviously, please don't say, people have done this before, and I just have a field day with writing a little note on their paper. If you say 2.05 here, I'm like, 2.05 inch tall dude. Right?
Yeah, maybe a 0.98.
If this side is 2%.
I think.
Okay. So how do I go from here back to a height? This is a z-score, right? Because we got it from the z-score chart. So how do I get back to a height? Well, how do I normally go from x to z? I use this, right? Let me stop here for a second. Is that right? Is that how I go from an x to a z-score? I use the z-score formula, right?
Now I want to go from a z-score back to an x. So all I got to do is use the same formula. Some of you guys could just plug it in there, but we're going to do a little algebra because we're smart people. We realize how important algebra is. How do I... Now, this is really kick-ass formula if I know these three things. Right now, what do I know? I know z is 2.05. I know the mean is 69. I know the standard deviation is 2.8. I know these three things. So let's solve this sucker for x. Let's make a more useful formula for that situation. This is why you did that in algebra. You just played around with stuff with only letters in it, because it's important to know how to do that. How do I solve this for x? Multiply by the good, which is standard deviation. All right, it makes sense. What's the worst part about this, besides the fact that I'm asking you to think about it, is the fact that there's a fraction on the side. It's an equation. You can kill the frickin' fractions when they're in an equation. If they're not in an equation, too bad. You got to let them live. It's in an equation. It's my domain. I can kill it. So I can multiply both sides by sigma. Dead. So now I got z sigma equals x minus the mean. One more step to get x by itself.
You
Add mu. I like it. So I get x equals mu plus z sigma. You right like that. Do you realize that is the same formula as that, just reorganized in a more useful fashion for certain times? And what do you guys remember the one question I'm going to ask you on every single test? No. All right. You always want to know what's on a test, and then you forget it. Yes. I'm going to ask you, what does the z-score tell you? Right? And maybe about 40% of you got it right the first test. That was exciting. This, I don't let you have notes on the formula sheet, but this formula is a note. Watch, watch, watch. How do I get to a data point? I start at the mean, and I go this many standard deviations. So what's the z-score tell you? The number of standard deviations from the mean to the data point. Just about every equation is a sentence. It's a sentence that's written in a weird language. But here I can translate this into a English sentence, holy shit, which turns out to be the definition of z-score, which is what I'm going to ask you. Oh my God. And you'll still find a way to get it wrong. Sorry. It's hard to be optimistic when I'm proven wrong every semester. Or proven right with that part. So what do I know on that part B? What do I know? I know the z-score, right? And let me point something out to you. If I'm at the mean, what area is there below me? What area is there below the mean? The mean cuts it in half. So what area is below the mean? 50%. I like. If I move up a little bit, now there's going to be more than 50%, maybe 58%. If I move up a little bit more, now there's 60-something%. If I move up a little more, now there's 70. So how far up do I have to move? So now there's 98% below me. That's another way to look at what we just did. You have to move up 2.05 steps, 2.05 standard deviations, so you end up at 98% below you. It's a really cool way to look at that. That's really what this chart says. As you move, how much area do you keep accumulating below you? That's another way to look at this chart. Kind of kicks ass. So if I move 2.05 standard deviations above the mean, that's what this formula calculates for me. Where do I end up? So what's x is going to be start at the mean and go 2.05 of these. Where do I end up? You end up confusing the shit out of us. Just plug it in an old calculator, right? Who is it? 74.74. I like inches. So this one, if I went to 74 inches tall, I have almost 4% of dudes trying to that have to duck. But if I took it up to 74.74 inches tall, if I want to be that exact, then I'm only going to have 2% of people that have to duck. this is related to that airplane problem I kind of alluded to. You can be more precise with this. If I only want 1% of people to complain, well, then how many tickets should I sell? You can kind of use this idea to figure that out. If I want, we have to make airplane seats a little wider for us. So if I want, 98% of people to be able to fit in an airplane seat, then how wide do I have to make it? Well, it depends on the average hip width, and it depends on the standard deviation of the hip widths, which they know. The industry knows this. You guys, so they want to control the number of complaints they get, right? This is how they can do it. Okay, I like it. So, you guys try out that number 2 on that handout.